So we'll probably only apply this effect on this background layer for now. We'll have to create a dynamic variable that updates in the main program that'll adjust how much the glowing or pulsating it's doing. Let's make some parameters here. Float, pulse. Let's first go back into GlowFX. I'm going to rename this as regular pixel shader. Regular. Or you could call it main. Main's a bit shorter. Alright, let's make another technique up here. And we'll call this bloom extractor. And this technique works in much the same way. At first, we'll get our input. We're going to be outputting as a color. I paused it for just a moment to add the code in here so you don't have to watch me type it all out. We set C color and we extract that from our texture or image. So in this case it'll be our background, looking up the original image color. So just like we did down here when we're using the sampler. And this saturate thing here clips it whatever the result is between 0 and 1 for each channel. So that way we have valid numbers. So we're going to go color minus the bloom threshold divided by 1 minus the bloom threshold. And as the comment here says, adjust it to keep only values brighter than the specified threshold. So between 0.25 and 0.5 are fairly effective for doing the bloom. We'll add a comment later for that. We're going to need to have a bloom threshold variable that we can pass in. So let's go up here, and we can go up actually up above the textures. I usually like to have the textures on top actually. Let's go below the textures. Of course we only have one here. And we'll type in float bloom threshold. We'll just have to remember to pass in the appropriate parameter. I mean, if you wanted and you know it's always going to stay the same, you could just change this to something like 0.25 for both these. Oops. Well, you get the picture. And then you wouldn't need this. In the first pass, we're going to select the technique bloom extractor instead of main pixel shader. And we're going to do that. Just a tip to keep in mind anytime you're doing shaders, I think in particular if you're using sprite batch and you're doing shaders, you'll want to make sure to sample the color first. For some reason, if you don't do it in that order, it can mess things up. So even if you have to do a dummy sample as the very first thing that you're doing in your shader, you should do that. And then anything else after that, anything goes. It doesn't matter the order that you do the texture sampling after that. But if, for example, we had a different texture, named something different, like texture 2 or something, and then we sampled texture 2, tc equals text2d, and we went textsamp2 and did a sample there of that one first. That could mess things up. You want to make sure you do that after that one. But I think that's just for sprite batch, and I think that's because of some assignment that's happening inside it before it uses the shader. And before we continue, let's make another technique. We'll call it bloom extract shader equals, so just the same as this. And then we'll change this from main PS to, actually we could put a PS on here if we wanted to, but I'm not going to. We'll just get rid of this PS and we'll just say bloom extractor. So when we select our technique, we're going to use bloom extract shader in quotes, and it'll know to use this one. Oh yeah, I guess too, if you're doing bloom threshold and you're never changing it, instead of passing it in here, I'm going to leave the option here though in case we want to. But you could instead go up here, say number defined, bloom threshold 0.25. Oops, it should be defined. And since we're up here, we're going to be doing Gaussian blurs. So let's put samples, and we'll go with 15 samples. You can change that however you see fit. Maybe you don't need as many. That's our sample count. You could change that to sample count if you wanted. I'm just kind of following the old example for doing Gaussian blur. Sample offsets, and say samples. Let's float 2 because it could have X or Y value. And float sample weights. So how much effect each one has. Alright, now we got to create our Gaussian blur pixel shader. So after the bloom extractor, let's put in Gaussian. I'm going to say float for, actually let's just copy what we had here and paste it here. And change this to Gaussian blur. Okay, so I paused and unpaused, and what I did here is we looped through the sample number that we specified above, which was 15. And what we do is we add up a number of colors that are weighted by some sample weight. So each one might be contributing 10%, 15%, or whatever to the final color. And we just add them together and return that as what the color is going to be. We're doing the regular sampling here from our texture. But instead of sampling directly from the regular texture coordinate, we're going to sample from that coordinate plus the sample offsets that we're going to set in the main program. That might be 0, 0 if we wanted the first sample to be exactly this coordinate. It could be 1 to the right, it could be 2 to the right, it could, if you're blurring horizontally, or to the left. And if you're blurring vertically, for example, it might be 1 above, 2 above, 3 above, whatever. And so we just add those up, each one contributing a percentage influence. So maybe one's only 1%, another one might be 5%. However many you need to get those 15 to add up to 100% of the color, of the final color that you're going to return here. So basically all we're doing is we're blurring, like as I said here, combine a number of surrounding pixel colors, which are weighted by percentage of influence, 0 to 1. Combine a number of surrounding pixel colors to influence the final color. In other words, we're going to blur it. And what we might do is blur horizontally and blur vertically to get the final color result, to get a full Gaussian blur. You could even set up the samples to go diagonal if you wanted, because these are X and Y values. I'm not sure why you would, but let's make sure we change this to Gaussian blur. And I'll just copy this so I don't have a spelling error. And we'll go down to here and set the technique Gaussian blur. And then I'm going to say shader, because this is a technique. Paste here, tell it that this is the function, and we'll say same as above. So now in the next pass we can pick, or on one of the render targets, we're going to pick to do Gaussian blur as our technique. Okay, the next is to combine the results on the two render targets, and we're going to need a shader for that. So then we're getting our actual bloom result. Oh yeah, our main texture I'm calling texture sampler. Let's just go down to our main pixel shader here and change sprite texture sampler to just texture sampler. It's just a little less to read. And then we'll go up to sprite texture sampler and change this to texture sampler. And we don't want to change this because I think that's what, or actually that might not matter in this case, because Monogame, I think internally in the sprite batcher, is setting the texture in a different way, but this should be in S0. So our next texture and texture sampler, I don't think we have to actually specify this, so I'm just going to go with sampler, and I'm going to call it base sampler. It's a sampler state. Make sure we put the semicolon after that, and texture is going to equal base texture. Make sure to set value in CS. Oh yes, in this case it'll be important that we set the register. So instead of saying equal sampler state, we're going to go register S1, because S0 is being used up here. And if we want, we can change these to this type of bracket. I don't think it matters which ones you use. And we could add filter here for setting up defaults. If we just say filter and then say linear, all the filters will be set to linear. So that's your near and far filtering as well as MIPS. Yeah, so we could say filter equals linear. We could say address U, clamp, address V, clamp, or we could say wrap, or we could say mirror. And there's another one, but I can't remember what it is. But we'll just let it use the defaults that are being set in Sprite Batch. Those ones will override this anyway, but we can set our defaults here if we want. Alright, let's go down under Gaussian blur and start our combine. Just pause for a moment, add the code right here. Okay, unpause. So I'm actually just right now just pasting this from some of my older code, and I'm changing my mind about how I want to do this. So let's go back up to base sampler. Just to me, right now it makes more sense. Instead of calling this base sampler, meaning we're going to be sampling from the base image, let's go with bloom sampler. And we can draw in the base image as the main image, so it doesn't have to be on its own render target. So I'll just call this bloom texture. Yeah, we'll pass it into bloom texture. And the base image we'll be drawing will go into here. So down in bloom combine, let's change the order that we're doing this, because we don't want to mess it up. It expects things to be in a certain order for some reason with the first texture. So float 4 base texture, base sampler, and then we'll go with bloom. And in this case, this should be texture sampler now, because now we're using a bloom sampler for our second texture. This will just be the regular texture image that the Sprite Batcher is trying to draw. And just for consistency, I'll put these in the same order. We're going to need a base saturation and a bloom saturation to pass in, as well as a base intensity and a bloom intensity to pass in. That way we can modify them for different types of bloom effects. So we're going to adjust the color, saturation, and intensity. Then we're going to darken down the base image in areas where there is a lot of bloom to prevent things from looking excessively burned out, which is what this is doing with the base sample. And we combine the two images. And we get whatever's left between 1 and bloom. We've got to saturate this though to make sure that it's between 0 and 1, so it's got to be a valid value. And so we're multiplying by that difference here, which does effectively what it says here. And then we can add that to our bloom value, which we got here. Now, we don't have an adjust saturation method yet, so let's add that next. It'll just be an extra function that we can call that bloom combine can use. I'll just add that up here above bloom combine. Adjust saturation. Helper for modifying the saturation of a color. So again, I just pasted this out of my old code. I can probably make this into one line. And a lot of this was taken from another older example made by someone else. So I'm not the original creator of this code, just to clarify. The original was from an XNA sample. What adjust saturation appears to do is we take a gray color that's pretty dark, 0.59 for the green value, which it says here are chosen because the human eye is more sensitive to light green. That's your middle channel. Less to blue, so your blue value is a little bit lower. Looks like we're doing getting a gray value that is a dot of the color that was brought in, dot product of the color that was brought in, and a saturation value. And then doing a linear interpolation, using the saturation as the amount to interpolate between the gray value that we got here and the original color. I'm not sure exactly how this works. It might be worth investigating if you're interested. But this will return a color with the amounts that we need in each channel, so that when we multiply by the base and 1 minus the saturation value of this, yeah, I'm actually not quite sure how this works. Anyway, I guess all you really need to know is this will give you a return value that can be used for adjusting the saturation, and that is done with this, in these two values here. You could also do a lookup of Cosmonaut, I think is what he's called, and bloom, Monogame, and Cosmonaut made a pretty interesting bloom technique that you might be able to adapt. You can find it in a GitHub repository. So there's that if you're interested. Alright, so this is on our bloom combine effect, or bloom combine pass. Let's make sure we set up a technique for that down here. I'm going to call it bloom combine shader. I'll just copy this here. I called it bloom combine. Letters are all correct. Okay. Now we also need to pass in the parameters. So let's go to the top and start adding those. So I just paused and unpaused. I added these ones here. intensity for bloom and base, and then bloom saturation and base saturation. Okay, let's make sure to save this effect. I would keep in mind too, we could actually leave this effect running throughout all the sprite batches. It wouldn't matter, because by default it's always going to be using this, which is the same as the original sprite effect. It's only when we select a different technique that it's going to be using one of these other pixel shaders. Alright, and so let's go set up creating the render targets and combining them in C# so we can create that effect and make it work. Back in game 1, I realized we're going to need a pulse direction too. Direction. What that does is pulse controls saturation for bloom, and pulse direction will control increase or decrease for pulse, causing it to pulse. Doki doki. Okay, next let's make sure we go over to the Explorer and right click on your project folder, and we'll add a new C# class called Bloom. Bloom. First thing I did was I added graphics device reference here. Just going to click the little light bulb and click to add the using. Oops, didn't work. There we go. Okay, it looks like we got none of them underlined now. I put an extra underscore in here, this glow effects thing, and I'm keeping it in here instead, since Bloom's probably the only place we're going to be using that particular effect. So, go back into game 1. We can just take this out of here, because we're going to use the Bloom class to process all of the Bloom effects. So we'll actually load this inside that class. I'll just have to put an underscore in between. Okay, so we'll change this later. First we'll go into Bloom and take care of the contents of Bloom. The next thing I added was a constructor, so we can pass in a reference for, actually I'll just put device here instead so it's less confusing. Or actually I could just put GPU in capital letters, I guess. And we pass in a reference to sprite batch so that these are basically the same instance, except in this class. Next, I added this load code here. There's an unload to dispose of the render targets after we're completely done with this. I'm going to click on the light bulb here. That'll add the using up here that we need for Content Manager. And then we can do like we did in the Game 1 class. We'll go glow effects and load it. Load glow. I'm getting the presentation parameters here so I can figure out width and height of the current back buffer and the color format. For the render targets that we're going to make, we're going to go with half the resolution. So I got this divide equals 2. And as stated here, these are half the size of the back buffer in order to reduce fill rate costs. Reducing the resolution in this way doesn't hurt quality because we're blurring the bloom images anyway. In fact, with a lot of effects, you can use half the resolution. If it's for like lighting effects or something like that, it's not really going to matter. So we set up render target 1 and render target 2 to be the same sort of thing. I paused it for a moment to add these variables at the top here. These are parameters that are going to be adjusted for our shader. We got the bloom threshold, brightness of pixel needed. 0 is equally, high values is brighter colors. We'll probably use 0.25 or 0.5. Blur amount controls the amount of blur applied to the image, range of about 1 to 10. We're going to be blurring horizontally and vertically. Bloom intensity, the amount of bloom mixed into the final scene, ranging 0 to 1. And the base intensity, the amount of the base mixed into the final scene, 0 to 1. The color saturation, the bloom saturation is the color saturation of the bloom image. 0 would probably be grayish, 1 is normal, and higher amounts, which is probably what we're going to use, will make it more colorful and glow. And base saturation, that's the color saturation of the base image or original image. Same sort of idea. Alright, next we'll go down under load and we'll add a draw method. Okay, so I just paused and unpaused this for a moment to change a couple of things. The first thing I did was under load If I come down here, you can see I added this draw method, and it inputs a source texture or a render target. A render target can be treated like a texture. And this is going to be the output here, the destination render target. So we'll pass it in by reference. Since they're objects, they're passed in by reference, as you already know probably. Then we're going to set our current technique to be gloweffects.techniques and bloom extract shader. You'll have to go to your effects file. Here, let's just make sure that's open. Go to here. I'm just going to make sure this is open. Okay, and I have most of this commented out just for the moment, and I'm going to uncomment it in baby steps to make sure that everything's going to work the way it should, and it'll all compile correctly. This is just the basic shader it's using right now, but the first thing we're going to need access to is this bloom extract shader, and that is the technique right there. So we'll copy that, and our extractor shader is called bloom extractor. It's up here. I can remove the comments for this. Okay, now if we go into here, we're going to set a bloom threshold. Going back to the effect, let's make sure that bloom threshold can be set. And back in Bloom CS, we're going to use this draw to target, which we're going to make in a second here, from our source, whatever it is. It could be a render target, it could be a source texture. And we're going to extract the bright parts and put them onto this render target 1. And then we're going to blur those bright parts horizontally here and vertically here. You'll notice that I have these commented out. I'll uncomment them now because we're going to create these shortly. That's to set up the parameters, that's the samples. So in here, we're going to set these pixel offsets and the weights. So how much of an effect each one will have. And that'll be for the horizontal and vertical blurring of that extraction. And since we haven't made these yet, they're underlined. We're passing in a width and height parameter here, and that's of the render target. I'll get back to this in a second. First, let's go to the draw to target, which I added down here. Draw to target, all it does is it takes the texture, or render target, and uses an effect, which we already applied up here, the bloom extract shader. It sets that render target here, and then we do draw full screen quad, drawing the render target or texture, and it'll be rendered onto this render target. And we're providing a render target width and height. So if we go down here, this is basically the remainder of the code that is substituted here. Now, the first thing we'll need to do is clear that render target. The pixels won't necessarily be transparent on there. We may have used it a few times already. So we must make sure that it's clear. It'll probably be just black if it's not clear. So we want the alpha transparency 100% see-through, so we can use it as a layer. You'll notice here your IntelliSense might not seem to work, or you may have this is underlined. If you have auto using extension turned on, if we go to the left here and we look at our extensions, you may have an auto extension, or auto using, I mean. So if you look for your auto using, you may want to disable that and restart. If you don't, you'll notice that it'll keep inserting system.drawing, which also has color. So then you have a conflict. And what we actually want is using Microsoft XNA framework, which has the colors in it. Now, instead of just typing that in, we could also go down here and click on color, and then you'll see a light bulb come up on the side. And we don't want system drawing. That's what the auto using will automatically select. We'll use Microsoft XNA framework, and it just added it up here for us. Okay, so let's go back down. And now we could also type in whatever, like if we wanted to go transparent black, we could do that. In the future, since that's the same as transparent anyway, that one might be gone, so we'll make sure we use the newer one, which is just transparent. Okay, so then we begin a batch. We're using alpha blending, and we've got to pass in our glow effects so that it sets that effect before it draws it, and it should be in deferred mode by default, I believe. That means that it's going to draw everything at once when it hits end, so it's going to set the graphics card states when this is called. It's going to set the graphic card states when it calls this, and then it'll draw everything that we wanted to draw. So any draws in here are not actually drawn until after it executes the command end, like I said, which sets the graphic card states and does all the drawing all at once in an optimal way. We only have one here, so it probably wouldn't matter if you said deferred or immediate or anything. It's not going to make any difference in this case. Actually, no, I wouldn't use immediate. If you're using immediate, I think you have to set your parameters right before the actual draw, because it'll actually do the drawing right here. So it's preferable we not use immediate and use something else and then let it draw here, because that way we can set our values up here, our techniques and values up here, and not worry about it. We're not setting our techniques either for the blurring, so we're going to have to add that in here. And we'll also have to set our technique for combined, so we haven't added those yet. Let's go ahead though, before we fix this, let's add set blur effect parameters, and then we'll come back here and fix this. So we could do that above or below draw, whichever you prefer. I suppose I'll do it below. Alright, and pause it again, and I added this set blur effect, which we're going to use up here, and that takes these width and height value, dx and dy, and I believe that's a regular pixel amount that we're going to use for our offsets. So that's why up here we're saying 1, which is the maximum width of the screen, divided by the render target width. So now we're getting, instead of the width of the screen, we're getting the width of 1 pixel in terms of 0 to 1. So it might be 0.1 or something. Obviously smaller than that. And we do the same thing when we want to blur vertically. We're just giving it the height of a pixel in the 0 to 1 space that the graphics card will use. Let's go back down to set blur effect parameters. Okay, so that's what's passed in here, which will be used below. We're going to extract the weight parameter and the offsets parameter from our glow effects, and then from that we can look up how many samples our blur effect supports. So in our glow effect we define, oops, let's change this, samples as 15, and so when it builds this, these will be 15 for their count, so when it does that lookup it'll get 15. If we wanted, we could just put 15 here, say sample counts 15, and we could make that a constant. Now we temporarily create a couple of arrays and size them to that sample count. One for the weights and one for the offsets. Those are going to go into here in our shader. So then we set sample 0, which is just going to be at the regular pixel location. So we give it an offset of 0. And a weight, we use compute Gaussian 0. And what compute Gaussian does is it takes the value we pass in. We'll be using it here, n squared. This computes the weighting factor for our blur, and what it appears to do is get a 360 degrees times theta, or angular blur amount, and we're saying 1 divided by that, I'm not sure, by the square root of that, and then multiplying that by n squared divided by 2 times theta squared. I have no idea how they came up with this math. I'm not sure what it's doing here. I'd have to sit down and figure it out. But yeah, this will compute our blurring factor, or blurring weight. We probably could have just put 0 here. We don't even have to call this. I'll just leave it as is though. We can get the total number of weights by adding them up as we go through. Each one of these sample weights is going to have a weight value. And as we loop through this loop, we're just going to add up that total value. And we can use it for normalizing down here. I'm just going to go off the comments they provided here. Add pairs of additional sample taps positioned along a line in both directions from the center. So sampling surrounding pixels. So we go through the number of samples divided by 2. There's an explanation here for why that is, I think. Each time we compute a weight, and then we submit that weight into our sample weights as I times 2 plus 1. We've already done 0. That's why this is sample count divided by 2, because we're getting 2 of them every time we do a loop here. So we already did 0. So when this is 0, this will be 0. That means that this will be 1. and then this one will be 2, and the next pass it'll be 3 and 4, so, and then we just enter the same weight into each one. For total weights, we've got it times by 2 because we just did 2 of them. Now, I added a region around this comment here that explains it, but it won't let me collapse it, so I'm just going to go over to the side here to extensions, and I'm going to look for region, and there's something here that says region folder. I'm going to install that, and hopefully that'll allow me to collapse that. Alright, let's check it out. Yeah, it seems to be collapsed right now. So now I can click on this little arrow and expand and collapse it, and it'll be collapsed by default. Okay, I like that. So the explanation: to get the maximum amount of blurring from a limited number of pixel shader samples, we take advantage of the bilinear filtering hardware inside the texture fetch unit. If we position our texture coordinates exactly halfway between 2 text cells, the filtering unit will average them for us, giving 2 samples for the price of 1. This allows us to step in units of 2 texels per sample rather than just 1 at a time. The 1.5 offset kicks things off by positioning us nicely between 2 text cells. So you can think of texels as pixels on the surface that are going to be rendered to screen. So our sample offset is going to be I times 2 plus 1.5. Okay, and so that's why we're doing 2 at a time here. Our delta value is going to use that dx dy that we passed in, which will probably be 1, 0, and then the next time it'll be 0, 1, if you want to think of it in pixel coordinates. Obviously it's going to be 1 divided by the screen width, so it's going to be a much smaller number because we're doing this in terms of the 0 to 1 screen space. So how big those pixels are if they range from 0 to 1. And we're multiplying by the sample offset that we calculated here. So that's the pixel position difference in that 0 to 1 space. And this is the size of the pixel. So we're scaling this sample offset into that type of size. So then our sample offsets, just to make this clear that these are 2 separate things, I'm just going to say sample offset for this, so there's no confusion. So sample offsets, our array, kind of like we did here with the weights for our indexing, is going to equal to delta and negative delta. So horizontally it'll be to the right and to the left, vertically it'll be up and down. We could even go diagonal if we wanted to do something like that, but there's not really any reason for it. So I'm kind of trying to explain how this works, but I'm not the original creator of it, so I'm just kind of figuring it out as I go over it here, because I've never really investigated this code very thoroughly. I've just kind of used it up till now. So normalize the list of sampling weights so they will always sum to 1. And all this does is normalize the weight values. So if we have 15 samples, we want the total weights to add up to 1. If there was 3 samples and we wanted it to add up to 10, for example, then maybe one would be 3, the next one would be 5, which gives you 8, so the last one would have to be 2. So it just has to add up, and that's what we're doing here. We figured out the total weights by adding them as we went, which was right here, and we divide by that number at the end, so that each one of these is going to be the correct percentage, ranging from 0 to 1. And then we can do our weights parameter set value, sample weights. That'd be kind of like how we did before, where we went glow, effects, parameters, set sample weights, dot set value, or do we have to do dot set value? So I guess you could do it like that, but since we've already fetched that parameter, we have it as weights parameter, then we don't have to do that. We can just put it right in there, sample weights and sample offsets. And now they're in here. So that's set blur effect parameters. I'm not 100% sure if I understand all of this correctly, in particular this part, for how it determines that Gaussian blur weight, but I guess that's just how much influence. It's using some kind of technique of determining how much influence that pixel is going to have in the blur composition there. Okay, from whatever offset it's at. Let's go up. We're forgetting something. In here, we're not setting the appropriate techniques. So we don't have to change the technique after we do it for horizontal blur, because it'll be the same one for vertical blur. So let's just go glow, effects. Actually, let's just copy this line here. And make sure we set the correct shader. Go to Glow Effects, and we're going to want Gaussian Blur Shader. Just in case I misspell it, I'm going to copy it right from here and paste it in here. And to do the same sort of thing for down here, let's set the current technique. In this case, will be for combining, so the shader was called Bloom Combine Shader, which uses Bloom Combine. Paste Bloom Combine Shader into there. And we'll set the intensity, saturation. I think I went over all these, just giving you a general idea of what they do. I'm just going to quickly check to see how much of this is building. Found B, expected close bracket, 105,3. Oh, I've got these all on pass. These are supposed to be separate techniques, so this is a mistake. I just added this. It's a definition technique. I'll pull this to the left here for a second. Take in the name of the technique that we want to use, and then the vertex shader name, the pixel shader name, and that's just a macro to set this up. So it's basically doing the same thing that we got right here, substituting a technique name. So when I was putting in technique bloom extract shader, really what we would have wanted was to use the technique name. Whatever technique we come up with, it's going to go here. Vertex shader name is going to go here. And as you can see, this can be anything. This could be vertex shader, pixel shader. We could use this. It doesn't matter. It could be the same one for each one. What's important is we got the correct vertex shader name, which is going to be on this side. Well, the vertex shader is going to be the same as what Sprite Batch is already using. So we don't need to override the vertex shader. So you know what? We can take this vertex shader stuff completely out of here and just override the pixel shader in this particular case. In this case, let's just get rid of the vertex shader, unless you do want to do an override of the vertex shader, but you'd have to add that. So we just got this main PS as an override, Bloom Combine, Gaussian Blur, and Bloom Extractor as our 3 pixel shader overrides. Let's add the techniques down here using this technique thing that we just made. So, for example, instead of calling this Bloom Extract Shader, I could just go technique. Maybe I'll call it Extract Bloom. Sounds like a good name for the technique. Actually, we can keep main PS in here too. So we'll just say regular or default. We'll just call it default technique or default PS, I guess. Although it's not really a pixel shader. Yeah, we'll default tech because it's the name of the technique, and then main PS. That basically just did all of this with this line of code here. I'm just going to pause it and then we'll add the rest here. Okay, so we got our main PS right here. We got our Bloom Extractor here, Gaussian Blur, and Bloom Combine. We'll have to copy these and place them in the Bloom over here. So Bloom Extract Shader, we got to change that. We're not calling it that. We're calling it just Bloom Extract as the technique name. Then we're going to use Blur and we're going to use Combine. So paste. This will just be Blur technique or just Blur, and this one will be just Combine. There. And let's go back to GlowFX. We don't need this now, so let's pull this out of here. And let's save it. I'm thinking the rest of these should be okay. So I'm going to take these extra these comments off of here. So now that we know that everything that I had commented is no longer commented, it doesn't need to be. Let's just make sure we got these right, because this is from some of my older code. So we do have some mismatches here. This is position with a capital letter, color, text chords. So I usually like to keep things a bit shorter personally. It's easy to understand what text chord is for me. So input.text chord, input.color seems to be the same. And in these cases we're not colorizing these, so it's okay. Line 46. Oh, there's another problem. This I was using texture sampler. Let's just make sure this is register S0. Oh, it should be noted that there should be 2 O's in chord for all of these. I had 1 O here. So let's rebuild again. Click on the down arrow to see the errors. Dot implication truncation of vector type. Line 68. Okay, that was probably a warning. Let's check that again. Unrecognized identifier of VS output on line 74. I could change this to VS output. It's a little less to look at. Then I'd have to do that all over here. Let's just copy this and paste it wherever you need to. Input.texture coordinates. I think this has to be text chord. 2 O's. Now, Control S to save, and then we'll rebuild. And they give us a warning. Implicit truncation of vector type. Line 68. That'll be okay. Now, in here, I took out the glow effects because we're going to be processing that with Bloom. First, I want to make sure everything still runs. Hit F5. Okay, looks good. Now we'll create our Bloom object, and then we can use it. And then we'll want to animate the pulse, so we'll animate the saturation, or the glow. I guess first we'll add a Bloom here, and then we'll create an instance of it down here. Perhaps we'll do that actually in load, so we can do it all together at once. So I'll say Bloom is equal to new Bloom, send it a reference to the GPU and the sprite batch. And then I'll say Bloom.load content. Pass in the content manager. That should load up the glow effects. And now to use it, let's go down here. Since it's going to be doing its own begin and end, well, I guess we could render anything we want on this layer onto that far background and then send it as a render target. The other thing we could do is just send the texture, because that's the only thing that we're going to send in this instance. So let's do that. We'll just send the texture itself. So all we have to do is go bloom.draw far background, and then we want the destination rectangle. So some render target, or I guess I could say back. Yeah, I'll just say render target, render targ1. We can get rid of these because it's got its own end in there. Now we've got to create a render target because we don't have one. Render targ1. Oh yeah, and here we're setting up our graphics. I think it's pretty safe to say most of the time now we're going to be using high def for the graphics profile. If you need compatibility with older devices or DirectX 9, you'd probably use Reach. So we'll say graphics profile dot high def, and that'll let us use shader version 4 or shader version 5, and so on. Oh yeah, I had to create another render target. Let's just copy this line here and call this render. Oops, is it small? Render targ1. Yep. And that is equal to, we'll give it full resolution. Same format. In this case, we don't need any depth information. I don't know. We might, depending on what we want to do. We'll just leave it. On second thought, no, I don't think we'll use any depth information with that. So now rend targ1 will contain our scene, and then we would just draw rend targ1 as a layer. Okay, so it occurred to me that this cannot go here. If we put this graphics profile thing in here, or any changes to graphics here, we want to make sure we put GPU equals graphics device after we've applied our changes. To be safe, I put presentation parameters pp is equal to graphics device dot presentation parameters, and then I put that in as the back buffer format. It should just be like surface format dot color, but just to be safe, we'll use the current presentation parameters back buffer format with our main target. Now this should be working, but you should get a black screen at first. We haven't set any parameters yet. So going into Bloom, we go into the Bloom constructor here. If we wanted, we could add an extra parameter for selecting a type of Bloom, which has a type of settings. But we're just going to manually specify some desirable settings here for like bloom threshold and saturation intensity and all that. So we'll start with threshold is equal to, I'll just type these in and then I'll unpause it. So I'll pause it now. Okay, so what I got here was I set bloom threshold to 0.25, blur amount to 4, intensity to 2, and base intensity to 1, bloom saturation to 2, and base saturation to 0. I suppose you can toy around with these numbers, or just look at the old X in the example and see what they have in their table. Okay, I'm going to hit F5 and try it out. And it works very well. That is a very saturated background. Now to make it pulse, that'll make it look a lot more cool. Let's go to Game. And we want this pulse to control the saturation. So normally we have the saturation, I think it was 0.25. Maybe we'll make it bounce back and forth between 0.1 and 0.3. So we'll try out different things and see what we get. So in Game 1, we're going to have the pulse direction change when it reaches the maximum or minimum amount. So it'll be -1 or +1. We'll go to Update, adjust bloom saturation, make it pulse. So we'll say pulse plus equals pulse direction. And we should set an initial pulse direction. So we could initialize it here if we want to say 0,1F. Then I can say if pulse is greater than 0.3 or whatever amount you think will work. Then we'll say pulse is equal to -0.1 F. If pulse is less than, say 0.1, say pulse is equal to, oh wait, 0.01 F. There we go. This should be -0.1. We'll set the starting amount at 0.1. Let us also update the parameter. So bloom dot base saturation, bloom saturation is equal to pulse. We'll try it out, F5. Okay, so I gotta figure out why that's not working. How about we start with the extremely obvious here. This should be pulse direction. Because otherwise pulse is never going to change. Hit F5 again. 0.3 might be a bit high. Okay, wasn't the result I expected. Oh, I know why. I was thinking of bloom threshold. So that's the level of brightness that it'll extract. And we were supposed to be working with saturation. Now that should be more like maybe 2 to 4. We could try bouncing both of them and see what happens. We could play with all of these numbers actually. But let us go with saturation maybe 2 to 4. We'll try that. So greater than 4 and less than 2, I guess. The change is a little bit on the slow side. So let's bring this up. And we'll have to do that here too. 5. Okay, that works. It's a little bit faster than I want it. 0.5. We can just keep toying with these numbers until, like, also we can go into here and change these numbers too to try to get more desirable results. That's actually a pretty cool background. So I'll leave it at that for this tutorial example. It's a bit of a learning process for me too, because this is the only time I've started from scratch in Linux, and this is under Linux Mint this time. And previously I was working with MonoDevelop. So this is all under Visual Studio Code, which I have used before. But things are a little bit different this time. Well, hopefully that was useful to someone. And until next time. Oh yes, one last thing I forgot I wanted to add. Markus from the Monogame community has been working on setting up a fork for Monogame that will allow us to use a new kind of effects builder other than Mojo Shader. I can't remember what it's called offhand, I'll have to check. But it'll allow us to use new versions of OpenGL, and we'll no longer need to use Wine and compile exclusively with Mojo Shader. You can still use Mojo Shader with it, but by default it'll tie into the other, I can't remember what it's called now. Just a moment, I'm just gonna, oh yeah, here it is. There's a post about it on Monogame community. So this is still being worked on, but it should be in working condition, I think. So it can use Mojo Shader still. You have to add a define for that, but I think by default it'll be using Shader Conductor, and that'll give us access to Shader Model 4 and 5 in OpenGL, and you'll no longer need to use Wine. So the setup might be a bit different, so there might be some slightly different instructions that you may want to check out. There's some documentation in the GitHub for it on how to set up and what minor differences there are, like for setting up the Monogame content builder. And so now you'll be able to use geometry shaders, compute shaders, I believe hull and domain are supported, tessellation shaders. So very interesting stuff. You'll be able to do very advanced graphics. Okay, so this is just an additional update to what we were working on. In bloom.cs, before we were saying to use the presentation parameters back buffer width and back buffer height. That's good if you're using full screen mode, but since we're using a render target that may have a different resolution, well, it will have a different resolution if you've been using the exact same code here. The resolution we used was 1024 and 768, so you can put those in directly if you want, or you can pass it in from the main target. I'll leave that up to you. I just left some extra comments here and commented this out. And the reason for that is this is more efficient with the video RAM, because the full display would be our desktop display, which is a higher resolution. So we didn't really want to do that. We just want to use our lower resolution that we're using in our game. Okay, and that is all I have, I guess. Hopefully this has been helpful. Have a nice day.